All right, this is the Unit 10 test study guide. Topic number 1 is on sequences, specifically explicit and recursive formulas. All right, so we've got a couple just definitions to know with this first part here. A sequence is a list of numbers that follow a particular pattern. So like it says up in the topic name there are 2 different ways that we could define that pattern, either recursively or explicitly, meaning based on a formula or based on the previous term. So that's what we are talking about with this next one, the difference between recursive and explicit. A recursive formula it's based on the previous term. So let's say it requires knowledge of previous terms. And then the explicit, so where an explicit formula only uses the term number. Okay, so you really want to know the difference between those 2 types of sequences that we could have. So we've got formula. This one is defined recursively. You can see a sub n is based on a sub n minus 1. So the first 6 terms, it includes the one that you were given already. So you get to count the -1 as part of your 6 terms. So -1, and then for each one of these, you double it and then subtract 5. So 2 times -1 minus 5 would be -7. And then 2 times -7 minus 5 is -19. 2 times -19 is -38. Minus 5 is -43. 2 times -43 is -86. Minus 5 is -91. And last one, 2 times -91 is -182. Minus 85 would be -187. So just following that recursive formula. Number 4, we have the first 2 terms, and then you can see that it's got a combination of the one before and then 2 terms before. So first 2 terms are just 1 and 2, and then we follow this formula. So this is the one before squared, so 2 squared minus 1. So 2 squared is 4, minus 1 would be 3. And then 3 squared is 9, minus 2 would be 7. 7 squared is 49, minus 3 would be 46. Let's get a calculator for this one. 46 squared is 2116, and then minus 46. So 21, here's this, 46 squared, and then minus the one before, which is 7. So that would be 2109. Okay, number 5 is an explicit formula, so you just plug in the number to each one of these. This is almost like just making a table of values. So a sub n, so the first one, 3 times 1 is 3, minus 8 is -5. 3 times 2 is 6, minus 8 is -2. 3 times 3 is 9, minus 8 is 1. 3 times 4 is 12, minus 8 is 4. 3 times 5 is 15, minus 8 is 7. And 3 times 6 is 18, minus 8 is 10. Okay, number 6 is also defined using just an explicit formula. So we can plug in each value. So if you plug in 1, 1 minus 0 makes the exponent 0. So this 2 to the 0, negative 2 to the 0 is 1. So then multiply that by 1/4. Okay, then the next one, if I sub in 2, 2 minus 1 is 1. Negative 2 to the first power is -2. And when I multiply that by -1/4, I get -2/4, which reduces down to -1/2. The next one, if I plug in a 3, 3 minus 1 is 2. -2 to the second power is a +4, times 1/4 is 1. And you'll start to see a pattern here. Notice this is actually the formula for the geometric sequence, and these are getting multiplied by -2. All right, so times -2 times -2 times -2 times -2, and one more. So if you recognize the pattern, same thing here, like this is a slope of 3, so you could have just gone up 3 every time once you had the first value. All right, number 7, another explicit formula. So 1 plus 4 is 5, 1 plus 2 is 3, so 5 over 3. We'll see if any of these reduce. 2 plus 4, so 6 over 4, and 6 over 4 does reduce down to 3/2. Next is 3. 3 plus 4 is 7. 3 plus 2 is 5. Then 4. 4 plus 4 is 8. 4 plus 2 is 6. So 8 over 6 reduces down to 4 over 3. Next one, 5 plus 4 is 9. 5 plus 2 is 7. That does not reduce. And 6. 6 plus 4 is 10. 6 plus 2 is 8. And 10 over 8 reduces down to 5 over 4. And one last one here, another explicit formula. So n cubed minus n squared. So 1 cubed minus 1 squared is 1 minus 1, and that's 0. If I plug in 2, I get 8 minus 4, which is 4. Plug in 3, 27 minus 9, which is 18. Next value is 4, so this is 64 minus 16, and that's 48. 5 would be 125 minus 25, which is 100. And finally 6, this is 216, and then minus 36. So 216 minus 36 is 180.